Sandy.
Good,
Today
Pete.
we're going to be talking about SDAs. But first, I say we do a quick round of intros for everybody watching. My name's Pete. I'm the CEO here at Dagster Labs. And Sandy, you want to give your intro?
Yeah, I'm Sandy. I'm the lead engineer on the Dagster project. I've been working on Dagster for quite some time now and have built a set of the core abstractions that have gone into that product.
Nice. So why are you working on Dagster?
Yeah, it's been a bit of a long journey to get here. I started my career working on tools for data practitioners. So I was working on Hadoop and Spark, but I spent the big middle chunk of my career as a person not building those tools, but using those tools. So I was working at a few different organizations as a data scientist, machine learning engineer, data engineer, kind of the whole mush of activities that get different names. And then encountered a set of frustrations in those roles that led me to want to come back and work on infrastructure software to help those kinds of people, be more productive in their jobs.
Nice, nice. So you've kind of worked on both sides of the fence, right? You've worked on building tools and using tools and kind of going back and forth between them.
That's right. That's right. Exactly.
Yeah. I guess that gives you probably a pretty unique perspective, huh?
Yeah, I mean, I'd argue there are maybe like three different sides of that fence. I don't know if the fence metaphor still holds up, but there's people who are building data pipelines, and there's people within organizations who are building data platforms that help the people building data pipelines build those data pipelines.
Mm-hmm.
And then there are people building tools, more generalized tools like Dagster that help people build data platforms that help people build data pipelines. So it's kind of turtles all the way down.
So you're working on Dagster. This is a tool that helps data and ML engineers build and operate data pipelines. Presumably this is not a solved problem, right? So what are the top challenges that these data and ML engineers are finding with building and maintaining these data pipelines?
Yeah, great question. So I think that from the perspective of a data engineer and ML engineer, somebody who's trying to build a data pipeline, there's kind of two things that you care about. One of those things is productivity, which basically means being able to, build stuff fast, and improve and evolve the data pipelines that you have to the needs of your organization. The other one is, trust, reliability, confidence, where you want the data pipeline that you build and the outputs of that data pipeline, the data assets that it produces, to be trustworthy. So that the people who are relying on them, people that you're building it for, can actually trust that they're going to have the data that you care about. That data is not going to be stale, and that data will be useful to them. So the challenges that people tend to face in their data pipelines and data platforms are things that erode either productivity or trust. And probably the biggest eroder of both of those things is basically the chaos that kind of naturally creeps in when you have a sufficiently mature or large data platform. So you end up with your data warehouse littered with literally thousands, or in large organizations, hundreds of thousands of tables, and then you have these nests of, as you talked about, nests of DAGs, pipelines that are responsible for consuming and producing data, but you don't actually understand how anything relates to each other. So you'll end up with many versions of the same data in your warehouse, and no ability to understand which is the trustworthy one or why you should use one versus another. And then conversely, you'll have these data pipelines that are sort of trampling all over the place, maybe even updating the same data in inconsistent ways. And it's difficult to get a sort of legible, coherent view of what is going on and how everything relates to everything else.
I see. And so again, the topic of this conversation is software-defined assets, and I presume that SDAs would help you solve these types of problems. Can you kind of dig in there a little bit, maybe starting with what is a software-defined asset?
Yeah. Backing up. So when we use the word data asset, or just asset. What we're talking about is something that's produced or consumed by a data pipeline. In the most common case, it's a table, a data set, a machine learning model, maybe a report. So that's what we call a data asset. The idea of software-defined assets is that you build your data pipeline in terms of these assets. So the first thing that you think about when you're writing code to define a data pipeline is, what are the assets that this code is going to produce or consume? And so that means that by the time you finish defining your data pipeline, you have this declaration baked in of code of these relationships. So your pipeline will say, okay, we're going to start with this table, and then we're going to apply this transformation to it and get out this intermediate table, and then we're going to apply this transformation out to that and get this final data set that's useful for in some particular context. And so as you build your data pipeline, you're defining the assets that make up that data pipeline and the relationships between those assets.
Got it. But like, people have been building data pipelines for years, right? And they use things like, I don't know, Apache Airflow or something else like that to deliver these pipelines. Like, how is that? How like, I guess, what is new about the SDA approach, and how does that compare with existing approaches? Maybe like Apache Airflow would be a good example, since a lot of people know that technology.
Yeah, so it goes back to this idea of really centering the assets and thinking about the assets by default when you're defining your data pipeline. So Airflow, even though over its history it's largely been used for the production of data assets, a standard Airflow DAG does not have any idea of the assets that it's producing and consuming. So it's a DAG of tasks. So it says execute this task, and when that task is done, execute this other task. And in many cases, under the covers, those tasks are producing or consuming data assets. But that's not something that you're required to think about when you define a Airflow DAG.
And it's not made explicit, right?
That's right. Exactly.
Yeah. So like, sorry, I didn't mean to cut you off, Sandy, but it kind of sounds to me like SDAs are like this common language that different teams who are all participating in the same data platform can use to basically like collaborate on data pipelines that depend on each other. Am I thinking about this correctly?
Yeah, exactly. Right. So when you think about data pipelines in this way, you're kind of naturally defining the interfaces between teams. So like when you think about a data pipeline by and code up a data pipeline by defining what that data pipeline produces, you've sort of naturally built this interface to the data that you're responsible for maintaining. And that software-defined asset can then become the input to the next team's data pipeline. And you have the ability for tooling like Dagster to represent those relationships and make them legible to everyone within the organization.
Huh. Yeah, I mean, that sounds to me pretty similar. The move from like kind of workflow-based or task-based orchestration to asset-oriented. Would it be fair to call it asset-oriented orchestration of data pipelines?
Very fair.
Yeah, I mean, it almost sounds like the move from like kind of old school structured programming that had a lot of global state, and any line of code could touch any global variable, to like object-oriented programming or even functional programming that really values encapsulation and strict interfaces between modules.
Right.
Yeah, I think that, I mean, that's a fair way of framing this, right?
Yeah. I especially gravitate towards the functional interpretation, where in functional programming, you're really sort of encouraged to think about these like stateless functions that depend on other functions and produce data that can be used sort of further down. And Dagster is encouraging a similar pattern where every time you define an asset on top of another asset, you're not going down and modifying that asset. You don't have this kind of like imperative everything touches everything. You end up kind of building on top, and state travels in a DAG, or rather the data flows through a DAG, which makes it a lot easier to sort of
comprehend
what's going on.
Yeah. So comprehend what's going on. I think that's interesting. I actually saw a blog post recently about this. Everybody says that code is read more than it's written. And then this blog post, I think it was from last week, had another twist in it, which is like code is run a lot more than it's read or written. And so, or at least valuable code. And so understanding like how the software is running and being able to go in, like debug it and like predict what it's going to do when it goes into production is super important. Like, do SDAs help out with anything like that?
Yeah, I think it's kind of a critical piece of what maybe it differentiates Dagster from other systems that are just sort of providing maybe you call them data catalogs, other systems that are providing information about data assets, where Dagster really has deep context, is allowing you to understand how data is generated. So if you are interested in understanding, you come across some table in your warehouse and you want to understand how that table is produced, by capturing this relationship between the data pipeline or the computation that produces the table and the table itself, Dagster can give you a really faithful answer, not just about the past, not just this data was derived from this other data, but this is ultimately the code that is set up to be used in the future to continue updating this data. This is the schedule or set of conditions that code will be executed under. So you're able to understand the process that generates data as much as the data itself, which is really kind of critical for feeling that like you can trust a data asset.
Yeah, I think that's cool. I mean, that seems to align with like software engineering principles like coupling and cohesion or low coupling, high cohesion, and like the locality of behavior principle. So like when you talk about this sort of context that this software-defined assets-oriented approach can give you, like I mean, like I know we're talking about lineage, right? Like you can see the lineage of every data asset throughout the entire data platform, right? But is there other types of context here that SDAs can enable?
Yeah. So the what's sort of nice about the software-defined asset approach is that it provides sort of this scaffolding to hang a bunch of other features off of. So it's kind of like the core underlying data structure in Dagster is this graph of assets. So this set of dependencies between assets that Dagster is responsible for executing the computations to update. And then each of those assets you can attach sort of other metadata and constructs to that make you more able to understand the context behind those assets. To make that concrete, a feature that we recently shipped was data quality checks for assets. So for any Dagster asset, you can define a set of data quality checks that execute to verify properties of those assets. And when you go into Dagster to learn about an asset, you see all those data quality checks that are defined for it. So the producer of the asset is able to basically communicate a set of invariants about the asset that allowed consumers to understand more than, oh, this is a table with this name, but rather these columns are expected to have dates in this particular format. It's expected to have this many rows, etc.
Got it. That makes sense. And I suppose you can kind of get operational information about these things too, like when the last time they were materialized and whether they're successful or failed, that kind of thing.
That's right. Yeah. Those are kind of like table stakes features for an orchestrator, but having the assets linked in this way allows you to tie them to the health of the data asset rather than just the health of a particular computation that might not be relevant to a downstream consumer.
Got it. And as we're talking about assets, it's actually not really, from my observation, this kind of move from task-based data pipelines to asset-oriented is something that is happening like across the whole industry, right? Like, I mean, I would argue that like DBT in many ways is asset oriented. I mean, they call them models, right? But like it still kind of centers the deliverable data product at the end of the computation as opposed to the tasks that produce it. Is that right?
Yeah, I would 100% agree with you. And I think that's a big part of what's made DBT so successful and attractive is it lets people think about sort of the objects that are most important to them. And from the perspective of an analytics engineer, it's ultimately the tables, data sets that are capturing some understanding that they're trying to build. The other thing I would say is that it's really, while you don't necessarily see it in the most common orchestrators, if you look inside the data platforms of many companies, they've often built sort of asset-oriented frameworks on top on top of other tools. So like this is something that I've seen in a few places and worked on in other places as well. It's really common to essentially have an asset layer on top of Airflow, which can be kludgy for sort of a set of reasons, but speaks to the utility of being able to think about data pipelines and with that set of entities.
Nice. Yeah, and just transitioning a little bit here, you've talked a lot about this like asset graph and being a thing that you can hang a bunch of features off of. And so I thought back to our launch week, earlier this year, where we launched a bunch of stuff, including the data quality checks that you mentioned, the cost management tools via Dagster Insights, and our embedded ELT design pattern and library. Like, how does SDAs uniquely enable that?
Yeah. So we'll talk about a couple of features, one from launch week and one from outside launch week, because it's close to my heart, if you don't mind.
Yeah, go for it.
But yeah, so in terms of cost management, I think what one of the things that we found from talking to Dagster users was that they want to be able to basically attribute costs, and a natural entity for thinking about where spend is going in a data platform is, what are the assets that it's producing? And so being able to kind of deal with cost management and understand credit consumption in a more federated way by, being able to push it down to the assets that are actually responsible for those costs, makes it much easier for people to kind of divide and conquer and deal with and deal with that kind of like spiraling consumption out of control.
Got it.
So that's one piece. The other sort of feature that's really close to my heart is Dagster's asset-based automation system. So fundamentally, orchestrators are responsible for scheduling computations, automatically running the computations that keep data assets up to date. But the most typical way to set this up is via schedules. So you'll take some set of tasks, throw a schedule like daily or hourly on that tasks on those tasks, which doesn't really scale when you sort of try to think out to the level of an entire data platform, because you're stuck with either sort of building an Uber DAG over all of the assets in your data platform, or building a bunch of kind of like disconnected, smaller DAGs that have like unclear scheduling semantics between them. And so Dagster has taken this very asset-based approach to automatically running computations with its auto-materialized system. And the idea there is basically at the individual level of any particular asset, you can specify conditions under which that asset should be updated. Most typically, update the asset after the upstream asset that the asset depends on have seen updates. So you sort of naturally propagate data through the graph in this reactive way. And I think that's kind of like it's not the only way to do orchestration and scheduling in Dagster, but it's a very asset native way of doing scheduling that I think transfers a lot of the benefits of assets in general to this automation domain.
Nice. I mean, that sounds kind of like the move from imperative to declarative programming, right? Like you kind of describe, what the requirements are on the asset, and then let the system kind of figure out how to automate that for you.
Yeah, I think that's exactly the motivation there. Each asset has some sort of policy that describes, um, how it's kept up to date, and then that drives the automation system.
Awesome. Well, Sandy, thank you so much for talking to me about SDAs today. Is there anything else that you'd like to leave listeners or viewers with?
I think that is all I've got for today.
All right. Well, thank you. And where can people find you on the internet?
Yeah, if you type in Sandy Ryza, you can find my Twitter or my LinkedIn, my GitHub. So yeah, just check me out there.
For those that aren't aware, Twitter's the old name for X. So,
Thank
anyway,
you for the clarification.
all right. Great chatting, Sandy. Catch you later.
Likewise.